Oh. All right. All right, Chad, I'm going to press the record button. Recording the audio. Recording the video. We are ready. Let me guess, you want to talk about UFOs today? I just posted the video like an hour ago for last week's question show, and I feel like I called it. So I feel good, even though I was posting a week in advance. All right, hey everybody, how is it going? I hope you're all doing well. We've been busy. It's been cold, wet here. Every now and then, most of the time our June is quite nice, but every now and then you get a June that's just cold and miserable and pouring rain. We call that January, and I'm sure many people call it January, but it's been rough. Let's see. Okay. So as always, the way we're going to do this is I will answer some of the questions that were asked over the course of the last week, and then we will shift over and I will answer your questions live as part of the show. So go ahead, post in the any of the questions that you have. Nancy, I think I see Nancy in the chat there, so Nancy will grab them and add them to the list, and then I will go through them as quickly as I can. Some will end up in the show, some will not make it in the show, and it'll just be for us here live. And then at the end of this recording will disappear into the ether. It'll be but a memory, and we will all move on. Okay, awesome. All right, let's get into it. I'm feeling like I got lots of answerment in me, which I believe is the thing. I'm only seeing... Nancy, have you only picked one question so far? Because I'm only seeing the one from VidBoy4242. Have there been any other questions that have come through? Because if so, then there's a problem with the system. I see the problem. That fix it? Huh. Yes, okay, so you've also done the Zapfan 1 NASA budget, and why do people think black holes lead to another universe? Okay, awesome. All right, then we're working. All right, let's get into it. Chad, the system didn't ask me if I was recording or not. Okay, all right. Should probably have it go when I press the intro, not when I click on the first question. So, okay, here we go. Yeah, all right. Hey everyone, welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I will gather them up and I will answer them here. Now, once again, I'm recording this show on Monday, June 7th, 2021. So if anything really interesting happens over the course of the week from when I did the show to when you watch this episode, I didn't see it coming, and I'm sorry, and we'll have to deal with the fallout on the next week. But if you want to join the show live, which is where sort of the vast majority of the questions come in, I record these shows every Monday at 5 p.m. Pacific time on my YouTube channel, and you should totally join. And in fact, the real show is about 2 to 3 times longer than the one that you're watching, although there are no cool graphics, so you're gonna have to decide which way you want to go with that. All right, let's get into the questions. All right. Yes, I am recording, Chad. Okay. Yeah, I'm only seeing a couple. So if you maybe they got tagged into the wrong section, Nancy, let me know. Canon Lucas, that's a 70 millimeter apochromatic refractor. It's a stellar view, and I never use it. I am into astrophotography, but I like to use a remote telescope provided by OPT, which is a really cool 11-inch Rasa, which is great. Although we haven't used it for a while because of all kinds of technical issues that I can't really go into. All right, let's get into the question. Diversified input. Hey, Fraser, what is space dust? Where does it come from? I always talk about space dust here on the channel and how dust is, the answer is that it's always dust. Are we perceiving primordial gravitational waves? Nope, it's space dust. Are we measuring ourselves at the center of the universe? Nope, just dust. At every time, space dust pokes up its head and is the cause of so many issues for astronomers. And in many cases, if it's interesting, it's probably dust. But what is it, right? Like, we know it's like stuff out there in space, but what is the dust? And so I actually didn't know before I took this question on and started to do a bit more research. I just sort of assumed it's like bits of dirt in space. But how do you get bits of dirt in space? What's making dirt? If the universe all started with hydrogen and helium, how do we end up with dust? So there's a bunch of sources, many different sources of dust. So here in the solar system, for example, we have the dust that's left over from the formation of the solar system. And that's sort of raining down on the Earth all the time. In fact, many tons of it are being added to the Earth every day. And so that is just little pieces of debris from asteroids that crashed into each other. You've got the zodiacal dust, which we now know is actually the dust coming off of Mars that's being blown off into the solar system. You've got bits of material that's coming off of comets and asteroids as they're getting too close to the sun and blowing that material out. So you've got that. But then you've got the interstellar dust. You've got these incredible dark nebulae that you can see that are blocked. You've got all of the dust lanes that are caused down at the center of the Milky Way. And where are those coming from? And there's two main sources of dust. The one source is when you've got stars that are more massive than the sun, that as they reach the end of their life, they turn into red giant stars. And in the core of the red giant, you've got all these processes that are creating fusion, that are fusing heavier and heavier elements inside the star. And eventually you're getting to the point where you've got small pieces of the precursors of dust starting to form inside the star. And they make their way through the star, and then they're blasted out by these really powerful solar winds that are coming out of these stars. So things like Betelgeuse are releasing large amounts of this dust out into space, and it's being formed inside the star, making its way out and then blasting out into the universe. And then the other source, and this has only recently been figured out in the last couple of years, is when a really big star like a supernova goes off as a supernova, like a really massive star. The star detonates, and you've got all of the gas that this supernova had released into space in the millennia before it actually detonated as a supernova. And all of the material kind of coming out of the star crashes into all of this surrounding cocoon of gas that had already been released. And it slows down and forms dust in this region as it's happening. And so then you're getting all of this material, you've got the original material blasted out by this star as the supernova, and then you've got the actual supernova event crashing into it, and you're getting dust forming at that point, and then it's sort of pushing outward. And that we know that this dust makes its way into star systems, into clouds of hydrogen and helium, and helps to collapse these down into star systems, and the dust seeds the heavier elements into the solar system, and then it gets recycled. And so when you think about, that famous quote from Carl Sagan that we're all made of stardust, and we are, that all of the heavier elements, the carbon, all of the silicon that's around us, all of the phosphorus and nitrogen and all these kinds of things, these were all formed either in these giant stars as they were dying, or supernova detonations, which I guess is giant stars dying. So it's kind of fascinating to think that all that stuff came from those sources, and it's everywhere across within the Milky Way. Great question. Peter Michaels. The Kardashev scale makes no sense to me. Why rank civilizations by the amount of energy they consume? So the Kardashev scale was this scale that was developed by a Soviet researcher a few decades ago that said that as a civilization gains in its ability, it's going to be continuing to use more and more energy. And if you just take the amount of energy that humanity has used over the history of our lifetime for a million years, however long human beings have been around, you can plot this energy curve that grows in an exponential fashion. It just goes up and up and up and up. And eventually you get to the point where the amount of energy that a civilization is going to use matches the total amount of sunlight that is falling on the planet. And this, Kardashev said, well, that's going to be a type 1 civilization. At that point, the civilization is using 100% of the energy that's falling on it. And then you can continue to plot that energy curve up, and you say, well, at some point, the civilization is going to be using all of the energy that's being released by the star. And that is a type 2 civilization. And then you keep plotting up the amount of energy. You say, well, at some point, it's going to be using all of the energy that's used by all of the stars in the entire galaxy. And that was defined as a type 3 civilization. Now, why do that? It's not like using more and more energy is some kind of aspirational goal, and that's how we judge a good civilization from a bad civilization. It's just how we recognize the existence of a civilization, because in theory, a civilization that is using all of the energy from its star, a type 2 civilization, should be detectable by the fact that they will have enclosed their star in some kind of either sphere or swarm, and it will be then absorbing the visible light in various wavelengths, and then it's going to be giving off infrared into space. And it's going to be that infrared signal that's the thing that's detectable. Now, does that mean that they are the most metaphysically advanced civilization out there in the universe? No, they're horrible gas star chugging monsters that are they're gobbling up energy, and they've already destroyed all of the planets, and they're the worst. But we can detect them. So, are they the obviously it's all about your definition of advanced. Do they have the best technology? Who knows? But what we do know is we should be able to see them, and that's it. And so if you want to come up with other measurements, the ones that have achieved a higher state of balance with the ecological system that they find themselves within, it's a really interesting idea. They would just be really tricky to spot, because they just look like a terrestrial planet, and it's really hard to find them. So that's the only reason that scale exists. Not like it's some kind of aspirational goal for the future of humanity. Like let's not rest until we've enclosed every star in the Milky Way in a Dyson sphere. No, it's just we would note if someone had already done that. Pear Boo. Could life on Earth be von Neumann probes? Perhaps DNA-based life is just a very fancy self-replicating robot system with an extremely clever improving method, evolution. We could have been seeded into the Earth billions of years ago, and through humanity, we are reaching our singularity, meaning that complex behavior, learning, and exploration capacity are accelerating further and further. Sure, one perfectly legitimate explanation for the source of life here on Earth is that it was seeded a long time ago by some alien civilization, either intentionally or unintentionally through panspermia, that at some point life that formed in some other location around the Milky Way found its way into the solar system and was able to take hold and go. And when you look at, say, the Hawaiian Islands, that there's all kinds of life on the Hawaiian Islands, and scientists there are able to trace back pretty much each one of those life forms to the moment, like how long ago that it arrived. And they weren't coming very quickly. Like every few thousand years, a new species would arrive on Hawaii. Like, oh, now we've got frogs, and now we've got this kind of grass. Now we've got this sort of bird. It's kind of an interesting idea. So you could absolutely postulate, sort of imagine that that at some point an alien civilization has built giant robot factories that produce DNA seeding capacity. They send these robot probes to various worlds. They somehow begin the process of seeding the life on that planet. But the one thing that we do know is that all life on Earth is related. And so, when you think about the alien movie, was it Prometheus? Anyway, where you've got this life form that dies on Earth, and then you get various life forms after that. That's fine as long as it can all trace a common ancestor back to a single event. And so us and fungi and plants and cyanobacteria and archaea, we all share a common ancestor. And so that would be the method. So if you do sort of decide that, that's great, but then it just pushes the question back. You're like, okay, fine. So then how did life form? If life on Earth was delivered by some alien robot system, then where did the life form to build the robots? And then if they were seeded by life, then where did the life form to build those alien robots? And at some point, there had to be some kind of abiogenesis, some moment where you had non-life and then you had life in the entire Milky Way. But it's a perfectly consistent way to think about how life came to the Earth. All right, so those were the prepared questions, and now I'm going to go through the live questions. So let's see. I haven't even looked at them yet. Okay, let's see this one here. Boston sucks. Hey Fraser, I have an 8-inch Dobsonian, and I was wondering if there are any objects that are visible every night from Vancouver. I can't always wait for the full moon every month. Thanks. Wait, you want to wait for the full moon? The full moon is the enemy. You want to avoid the full moon. You want to use the rest of the month, except for when there's a full moon. Like when the full moon is out, you put your telescope away. But every other phase of the moon, for example, is wonderful. The thin sliver moons, the quarter moons, half moons, waning, waxing. That's when you get to see different craters at different parts of the moon. And so the full moon is the worst. So don't look at the moon when it's a full moon. In fact, don't do anything with your telescope. But what else can you see? Well, the night sky is changing all the time. And so different times of the year have different planets that are visible. Sometimes you're going to have Venus, you're going to have Mars, Jupiter, Saturn, Mercury, depending if you have a view to the horizon. I'm not sure where you are in Vancouver. If you've got a more powerful telescope, you should be able to see Uranus, maybe even Neptune. You're going to have asteroids that are going to be shifting through the night sky. So those are all fairly bright objects that you can see even in the city lights of a place like Vancouver. Now, there are some other fainter objects that you can see as well. And again, these depend on the time of the year. So during the summer, you can see all the various summer constellations. You can see the Great Globular Cluster in Hercules. You can see some of the open star clusters in, say, Perseus. In the wintertime, you can see the Great Nebula in Orion. You can see stuff in the spring. So there are fairly bright objects. You see Pleiades. But then if you actually want to go outside of the city, then you can get a lot more deep sky objects. And an 8-inch Dobsonian is like the perfect machine for that. Once you learn the night sky, you can point the telescope at different objects and start to really see them. So highly recommend that. But no, you're going to have to find out, just keep track of the locations of the planets and what time they're rising and where they are in the sky and be able to point. And every now and then things get really great, like Venus reaches its brightest point, its closest point. You can see, well, it's always sort of the same. You just see clouds. But Saturn especially has points when it's closer to us than other times of the year. Same thing with Jupiter and its moons, and Mars, especially every 2 years, gets closer and brighter. So you're going to have to keep track of what's going on in the night sky. And yeah, put that telescope away when the full moon's out. That's the time that you just leave it closed. Zapfan, what do you think of the proposed NASA budget? I haven't looked at the new NASA budget, so I don't have any opinion. But in general, I highly recommend, if you listen to Casey Dreyer on, I've interviewed him here a few times in the past, but if you listen to the Planetary Society, their planetary radio, they do a space wonk cast every month or so, and they talk about all the various space policy budgets, things like that. It's fascinating stuff to sort of understand how space policy gets made. So I highly recommend that. All right, let's see this one here. Cootie Exo. Why do people think that black holes lead to another universe? It sort of depends on who you ask. The answer is that we don't know what is on the other side of an event horizon of a black hole. What we do know is that when really massive stars, much more massive than our sun, die, they explode as a supernova, and then all of the layers come crashing in, and they implode at the center. And so you have all the mass that was once a chunk of the star is now this object that is so densely held together that it the escape velocity to leave this object exceeds the speed of light. And so when you kind of imagine, like, what's the escape velocity to leave Earth? How hard would you have to be able to jump to be able to escape Earth forever? It's fast. It's like, I forget the exact number. 7 something kilometers per second, 8.1. Anyway, I'll let Chad edit that out. But if the Earth was more massive, then the speed that you would have to jump off of the Earth to fly off into space would be more. Maybe it would be 15 kilometers per second. If you were going to, even more massive, maybe it would be hundreds of kilometers per second, thousands of kilometers per second. Well, the speed you would have to jump to get off of a black hole is beyond 300,000 kilometers per second. And that's the speed of light. And so not even light can jump off of a black hole. So is that a portal to another universe, or is that just a really, really massive, dense, planet-like thing that you could just fall into and get crushed onto? We don't know. Maybe a black hole tears open the fabric of the cosmos and leads this portal to another universe. Or maybe if you just jumped into a black hole, you would just go smack onto the black hole at a ludicrously fast speed and just be pasted out onto the surface of the black hole at 1 atom thick. So I don't recommend that you try. Just wait for the scientists to figure out exactly what's going on before you plan your journey to a black hole. Yeah, that's a great question. DStonks333. We seem to be seeing a lot of asteroids coming near Earth. Are we just getting better at finding them, or is it something else? We are getting better at finding them. For the longest time, asteroids were found by astronomers, professional and amateur astronomers who go out every night. They would take their telescope, they would look in the sky, and they would look for an object that they didn't recognize as part of some constellation, an additional star. And then they'd go out the next night, and they'd look again, and they'd be like, wait a minute, that star has moved. I wonder if that's an asteroid. And then they would trace its position, and then they'd start to figure this out. And then astronomers got access to, say, CCD cameras, where they could go out and they could take a bunch of pictures, and then they could flash the pictures one at a time. They could see any little objects that are blinking back and forth, and that would tell you that you got some asteroids in the picture. And it was from this process that astronomers started to realize that we're actually in a bit of a shooting gallery, that there are actually tens of thousands of near-Earth objects, which, if they hit the Earth, could cause a lot of damage. But in the last couple of years, we've got these automated sky surveys, and there are many of them. Things like the Catalina Sky Survey, where you've got these robotic telescopes that every single night are like clockwork, observing different chunks of the sky, downloading all this data. Computers are crunching through, and they're searching for the kinds of objects that are going to be in the sorts of orbits that are going to bring them really close to the Earth. But the problem is that we still have a few blind spots. It's really, really difficult to see objects that are coming at us from the sun. And so, especially from down here on Earth, the sun makes half of our day, 24 hours, difficult to see in. And so there are future plans to put telescopes out into space that will do the same survey, these robotic things, robotic methodology of scanning the sky. And in fact, because they're going to be space telescopes, they're going to have the ability to resolve objects that are far dimmer. So if you think we're seeing a lot of close call asteroids now, just you wait until this next generation of space robot asteroid finders comes online. It's going to be kind of terrifying when we realize what kind of a shooting gallery we're in. Like right now, astronomers know of about 30,000 near-Earth objects. And over the coming decades, that number is going to balloon up as we learn about more and more of them. So stay tuned. VidBoy4242. Hey Fraser, wouldn't you think that if we can track tens of thousands of pieces of debris encircling our planet, that we might have noticed UFOs coming and going? Well, sure, you would think that astronomers who have, as I just mentioned, powerful robotic telescopes that are scanning the sky every night, searching for anything which is moving through space, would find things that defy comprehension, that are unable to explain by any of our current scientific methods, and so far they have not. That the people who focus their work on the skies have not turned up any of this kind of thing. And so, like, what does that mean? Well, so the simple answer is that the aliens don't want to be seen. They've got alien technology, stealth drives, and they know where our telescopes are pointed. And the only time that they're seen is, when, I don't know, they're flying really close to people with cell phone cameras. I don't know. So, yeah, I mean, people who are into astronomy, obviously, we get asked all the time, if you've ever seen a UFO. And no, I've never seen anything that I couldn't identify. And when somebody shows me something that they can't identify, I typically have a guess on what it is that I think that they're looking at. And then there are people who, the stuff that even I would have no idea what it is. You've got people like Mick West, who spends a ton of time calculating the geometry and thinking about the kinds of camera systems and gear to be able to image various objects and what infrared camera systems are designed to look like. So yeah, I think, as we build more powerful observatories, both here on land and in space, and are able to scan more of the sky, if there was something coming from space, hopefully, if there is anything out there, we will have a better chance of spotting it, unless it uses super advanced technology that we can't do, or that it doesn't exist. All right. Jeff Sonderman. Hey, Fraser, would a spaceship with a warp drive be able to travel within the event horizon of a black hole and back out again? What would be the implications? It really depends on how your warp drive works. So, if you take Einstein's mathematics and you put in faster than the speed of light, then in theory, you should be able to escape a black hole. But the problem is that in reality, a black hole tangles up space-time so thoroughly that if you were flying your faster than light spaceship in the event horizon of a black hole, all pathways still take you to the singularity. So it's not about traveling so fast you can escape the black hole. The problem is that you're traveling the lines of space into the black hole again. All roads lead to the singularity. But it really just depends on how your warp drive works. If your warp drive allows you to create some sort of bubble that allows you to ignore the gravity, the sort of the bending and twisting of space-time caused by the black hole itself, then maybe you could escape from a black hole. We're going to have to wait till someone invents one, and then we can find out what happens. But I won't go first. Halley's Comet. Yeah. Will we land a probe? Oh, that'd be interesting. So that one's done. Apologies, just looking for some more questions. I don't know what the Blue Beam project is. Nicole Lillian asked me this. Does anybody know what that is? I don't know. Okay, I'm going to do this just because I want to talk about missions to Venus. Gregory Brown, with the recently announced missions to Venus, do you think that this will lead to other missions to try to penetrate deeper into the atmosphere of our gas giants? I mean, this is an interesting question, but I just wanted to use this as a chance to be super excited about the fact that NASA has announced 2 missions to Venus. You've got Veritas and you got Da Vinci Plus. Veritas is going to orbit Venus and scan the surface of Venus at a much higher resolution. Like right now, we've got like 30-meter resolution at Venus, while we've got sub-meter resolution at Mars. And yet Venus is way bigger than Mars, much more surface area. And there's these really fundamental questions, like how did this runaway greenhouse effect happen on Venus? Why does Venus not seem to have tectonic plates? Is there active volcanism on Venus right now? What's it made out of? What are the various minerals across? So having a really high detailed scanning mission going to Venus is really, really exciting. Like the last one that went to Venus was Magellan back in the 80s. So we haven't had really high resolution scans of the surface of Venus, and yet the technology has improved dramatically. Da Vinci Plus is going to drop a probe into the atmosphere of Venus. It's sort of a one-way trip. It's going to sample the atmosphere as it falls down through the atmosphere. That's exciting. I would prefer something that's stuck around a little longer in the atmosphere of Venus, maybe a balloon or airplane or something that could sample at different levels, but maybe we'll have to wait for the future. So does that idea scale to other planets in the solar system? Well, we've already sent a probe into Jupiter. When Galileo went, it released a probe into the atmosphere of Jupiter, and it's how we know what the upper atmosphere of Jupiter is made of, with water ices and ammonia ices, and then it died because you get down through the upper layers of the atmosphere, and then the density and pressure increase, and it's like hitting a brick wall, and the probe was crushed. And at the end of its mission, Galileo followed its probe into Jupiter, and the same thing happened to it. Cassini crashed into Saturn and didn't last long. And so the problem is that beyond the atmospheres of the gas giants, once you get down a little bit, the pressures and temperatures just get ridiculous. And so it's really hard to imagine any kind of probe that could stay in that environment and not just be destroyed. And you would need something that can float in pure hydrogen and helium. We've talked about this in the past. Like there isn't much that you can use. Like here on Earth, if you have helium is lighter than oxygen, and sort of less dense, and so you can have a balloon with helium that floats around. Same thing with hydrogen. Well, what kind of balloon floats in hydrogen and helium? Heated hydrogen and helium. So it would be really tricky to have anything that could last any amount of time. And so we've seen that probes, when you drop them into the giant planets, they don't last long. But I'm sure like an updated version of the Galileo probe would be useful and would tell us some new things, especially based on all the things we've learned about Jupiter thanks to Juno. We should send one of these every time with the latest, toughest hardware, with the latest science, and see if we can get as much new knowledge. But we're not going to get something that's going to nicely float around inside Jupiter or Saturn, swimming around in the hydrogen helium soup, unfortunately. But I'm super stoked. Although, I mean, we had to lose a mission to Io and a mission to Triton. So, a mission to Neptune's moons, which sucks. So, I'm sad that people even had to choose. Kyle Hunt, why does Starship have a header tank to store the landing burn fuel? Want to keep the fuel lower, closer to the engines? From my understanding, the goal is to keep it balanced and pressurized, separate from the rest of the fuel tanks that slosh around. But I don't specifically know that, so I'm not going to say that on any recorded method. Horizon Brave. But Fraser, about the scale, what if the civilization just found a way to not need to consume its stars? I feel like it's a very human way to only see them as having to consume. Sure, yeah. If the alien civilizations have figured out a way to not consume the stars, then we wouldn't be able to detect them. So it's entirely possible. But, an alien civilization that it is impossible for us to detect is the same as an alien civilization that doesn't exist from our perspective. So until we can find them, we have no way to know that they're there. People always, I get that quite a bit. Like, people would be like, yeah, but like, would we even recognize aliens if we saw them? And yeah, if we're capable of recognizing them, then we'd recognize them. If they're using energy and matter in the universe, then we would recognize that. We would watch as the heat given off by their spaceships. We'd detect the materials that they're using, the spectrographic signature of their material. But if they're not using energy and they're not using matter, they're using something else that we can't detect, then we can't detect it. Like, literally by definition. It's a tautology. We can't detect what we can't detect. All right. And I don't understand your other question about an orbital data center. I mean, I'm just thinking about transmission problems. How do you transmit your data back and forth? So if you're sure you could have a mass data storage in space, it would be cold, which would be nice, but I don't understand what you would, imagine the read-write times of going to space would be very slow. J McD, we'll do this one here. Matthew Jones, hey Fraser, sad to hear that Canadarm get hit by debris. Do you think Canada will replace it? Do you think future iterations will be on the other stations? They're still assessing the damage. It doesn't sound like it's that bad. So the arm is still working. I think they're going to check and see if there's any problem, but so far it looks like it's fine. It's Canadian built, it can handle it. Nothing. All right, and Kyle, I will answer this one. Kyle Hunt, what's the first resource that we will mine off the Earth? I would say the first thing we're going to be needing is water. That water's magic. You could take water, you can use electricity, you can break it up into hydrogen and oxygen. Hydrogen can be fuel with oxygen. You can use it obviously just for water, for drinking, for growing plants. You can use the oxygen for all kinds of things. You can use it in various industrial processes to mix with various metals. So if you've got water, you've got almost everything that you need. Like obviously you need some more heavier elements, carbon, metals, things like that, but water takes you a long way. And it's going to be one of the most precious things in the inner solar system. And there aren't a lot of places that we can get water. You're going to be getting water from the moon, from the permanently shadowed craters of the moon. You might be able to get water just from the rest of the lunar regolith or from various asteroids. If you just grind them up, there's going to be water inside, but not a lot. Most of the water is out beyond the frost line in the solar system, so out past the orbit of the asteroid belt, out to the moons of Jupiter and places like that. And so the inner solar system is rich in metals and rock and things like that, and the outer solar system is rich in water. And so you can imagine there's, in some vastly future solar system spanning civilization, there's going to be some kind of economy where the outer solar system is sending water to the inner solar system and the inners are sending metals, and the beltas are just caught in the middle as always. But obviously we got plenty of water here on Earth, so we're not going to bring that water back to Earth. The main purpose is going to be using that water in situ. You're going to want to use it where you're going to mine it where you need it. And so if you've got some, if you need rocket propellant, drink some water. Smart. So if you've got, some kind of propellant storage on the moon, you're going to be built right on top of one of these permanently shadowed lunar craters. You're going to be harvesting the water. You're going to be breaking it up, creating your rocket fuel, and then you're going to be able to send stuff away. It doesn't make sense to send any of this stuff. People are always like, when are we going to mine asteroids and bring it home? And we will never do that. It'll always be used in space as close as you can possibly mine it. 42, okay. Dennis Tyrant. When astronomers say the radius of the galaxy, do they refer to the radius of the disk, or does it include some part of the halo? The galaxy, the Milky Way, all galaxies really, have three different kinds of sizes. So the first one is just the stellar disk, and that's when you look at a picture of a galaxy and you see the spiral arms, that's the stellar disk. And so the stellar disk for the Milky Way is about 170 to 200,000 light years across. And then surrounding that is a sort of a disk of gas that surrounds, hot gas, essentially all of the gas that is blown out by all of the star formation that's happening inside the galaxy, and that's bigger. And then surrounding that is the entire dark matter halo of the galaxy. And usually like the dark matter is like a 10-to-1 amount of mass. So the dark matter is vastly bigger than what you can see in the Milky Way or any other galaxy. Like I think the Milky Way's dark matter halo is about 650,000 light years across. And the one for Andromeda is even bigger. And kind of the weird thing is like, we know that Andromeda is like, 1.5 million light years away from the Milky Way. And eventually in the far future, they're going to collide. Well, the reality is they're already starting to collide. Their dark matter halos are already starting to overlap. So, obviously, if you want to be pedantic, if a person says, like, how big is that galaxy? You're like, well, which part? The dark matter halo? The stellar halo? The gas? Tell it, you're going to need to be specific. Dennis Tyrant, what if there's an alien civilization that might not be from our universe? Would we be able to notice the difference? I don't know. How do you, like, if they're using energy and matter, then we wouldn't be able to tell the difference. If they're doing something else, then we might not be able to tell what they are. Would an airplane, Raphael Dominichini, it's a good question. I don't know the answer. Would an airplane work on Jupiter and Saturn? Sure, but I don't know what speed you need to maintain lift. Man, that's such a good question. So Raphael, I'm not going to answer the question here because I don't know the answer, but it's really good. And so I think I'm gonna take that question, and I'm gonna post that to Twitter, because often Twitter will give me like a really good answer. So I'm just gonna do that right now. There. So we'll find out. Usually scientists and stuff. There you go. I just posted it to Twitter. So keep an eye on my Twitter feed, Cain, Raphael, and we'll see if people get back with some answers for us. This is such a good question. I love it. Yeah. All right. Moving on. But another 15 minutes. Whoa. It's a good question. This isn't really a space question, but Steve Coates, how do we ever go about verifying whether an AI is actually conscious? That's the old Turing test, that if it acts like a duck, it quacks like a duck. Like, was it Rene Descartes? I think, therefore I am. Like, how do you verify that anyone around you is actually conscious and not just mindless zombies who are pretending to be conscious? You know that you're conscious, but you don't know that I'm conscious. I could be a simulacrum. You could be a brain in a vat, surrounded by a simulation of human beings. Now, of course, that's ridiculous to me because I know that I'm the one who's conscious. So being able to take that idea, I mean, you would assume that a sufficiently complicated artificial intelligence machine would be capable of pretending to be conscious, and you would have no way of telling the difference. So at a certain point, having some kind of definition for whether or not artificial intelligence is conscious is irrelevant. If it acts conscious, you've got to assume that it's conscious, because the consequences of causing harm to a conscious being is, it's kind of nasty. So assume that if you're having really deep and meaningful conversations with your plastic pal that's fun to be with, then assume it's conscious. But we will never know for sure. That's a philosophy question. That's way beyond my pay grade. All right, so I'm going to take this question on. All right. Oh, I deleted your question. That was not what I meant to do. Apologies. Here we go. Okay. Christopher Brown Floyd. Would there be any benefit to stationing a telescope in the outer solar system or launching one on an escape trajectory from the solar system? I get this question a lot, and I used to give this really flippant answer, which is just that space is really huge, and if you put a giant telescope far out in the solar system, it doesn't really make you closer to anything, but it takes you much farther away from the Earth, which is where we are. And so it's way harder to transmit data back to Earth. You've got to put all this fuel to be able to carry this telescope away. And when your telescope is out in the outer solar system, you're not really closer to stars. And in fact, when you think about it, your telescope is on the outside, this side, and now all those stars are farther away than when they are from the Earth. But it turns out there is an advantage to having a telescope in the outer solar system. In fact, this was just discovered by NASA's New Horizons spacecraft. New Horizons, of course, is the spacecraft that went to visit Pluto and Arakoth. And one of the interesting just science experiments that they did while they were out there was they just took the camera on New Horizons and they pointed it at some region of the sky and just were wondering, like, how good of a picture can we take now that we are farther away from the sun? And what they found was that, in fact, there is light pollution that is in the inner solar system. We talked about that idea of dust in the inner solar system. There is debris that glows inside the inner solar system. We're trapped right in the middle of it here on Earth. And so if you wanted the best possible telescope view, you would want to set your telescope outside of the inner solar system, way out beyond the Kuiper Belt, where it is like, it's like the dark skies of the solar system itself. That said, you still have all those problems of making it really difficult to send your data home. And so if you're going to be trying to take really good pictures and send gigabytes, terabytes of data home, you probably want to make a slightly bigger telescope, but leave it close to Earth, or maybe put it at the L2 Lagrange point, as opposed to building a smaller telescope and with an enormous transmitter and taking it all the way out to the outer solar system. But I love the fact that the reality is more complicated than I had originally assumed. So that's why I give a revision to my answer now. Arcast, do you listen to rap music? I don't anymore. I used to. I don't listen to any music anymore. I like to listen to podcasts. And so will you. Maybe not podcasts. Jasmine Stonechild, what do you think Space Force will accomplish? Is it even beneficial? Well, Space Force is not about having power-armored space marines loading up in their space battleships and flying off to battle aliens on the shoulder of Orion. Space Force is people down here on Earth in offices operating satellites that are observing the Earth. And so really, Space Force is all about using space assets to help people on Earth communicate, find their way, and observe each other. And eventually, they may be requiring defense of those satellites, but even that defense will be coming from Earth. And so Space Force is really people in offices, maybe like wearing suits, maybe they're in polo shirts, sitting in air-conditioned offices, maybe in the Nevada desert somewhere, typing code to check the status of their satellite. Space Force! It's not, again, people on the moon, etc. So there is already an enormous amount of military expenditure by many countries for their space assets. And so the purpose of Space Force was to really bring together all of those disparate assets into one umbrella group. Like you've got the Navy, you've got the Army, and now you've got Space Force. And they're managing all of these satellites that do all these tasks, some of which we are classified, and we don't even know what they do. So what will it accomplish? It'll do all the things it was already doing. It's just that there'll be one person in charge. And so if, instead of 5 different groups planning, talking to SpaceX, launching their own satellites, there'll just be one. Is it beneficial? Well, we rely on satellites for communication, for the GPS system, which was developed by the military, for all kinds of things. So if someone blew up your satellites, would that be a bad thing? Yes. So defending those would be a good thing. So I think that, in its current state, Space Force is fine. It's sort of already existed, just it wasn't in one group. Now, if they called it Starfleet, now we're talking. That's next level, but we'll get there. Ken and Lucas, what news about Juno and her low flight over Ganymede? No news yet. I mean, I hadn't seen news when I did my roundup this morning, but I think it's today, and so then we're going to wait for all the data to come in. This is so exciting that we're going to get these first images of Ganymede, like since the Voyagers, since Galileo. It's been a long time since we've had good pictures, and these aren't even going to be the best pictures that we're going to get. It's going to be the European Space Agency's JUICE mission, which is, you know, still like a decade out, that's going to really give us good pictures of Ganymede. But when you look at those, like, they're such low resolution, it's terrible. And so I'm really looking forward to it. If anyone's seen the pictures already, but I'm sure within the next couple of days, we'll be all oohing and ahhing over the pictures that Juno took. It's about time that Juno is taking pictures of moons of Jupiter. I mean, the pictures from Jupiter are great, but come on, let's see the pictures of the moons. I can't wait. And there's lots of great astronomers, citizen scientists on Twitter and stuff. Kevin Gill's my favorite. Check out his work. I'm sure he'll be all over this. It's only Kale. How about a telescope facing inward from 90 degrees off the ecliptic looking for objects and asteroids? Yeah, one of the most useful space telescopes is going to be something that is leading or following the Earth in orbit, so that it's got a different perspective of space. It'll be able to see the stuff that we can't see. There's an idea called Space Guard, where you're essentially looking at the Earth's blind spot to catch all the asteroids that we can't see, because a lot of them do come right out of the sun. They're diving down at the Earth from the sun, and we have no chance to see them. Any new podcasts? I don't have any new podcasts. I've got one called Revolutions that I'm listening to. So you may not know, but when people come on as patrons, I interview them, and so we talk for like 15 minutes to half an hour for each new patron who comes on board. This is a secret, but you know, don't tell anybody. And so when you come on as a patron, I send you an invitation, and then we chat on Zoom. And one of the questions that I ask everyone is like what's some content that I should be checking out? What's the thing that you love the most right now? And that's how I find almost all of the stuff. I find good television shows. I find really cool podcasts, and it's great because it's sort of like people who have the same interests as me are looking out for all the kinds of stuff that I haven't heard. So it's pretty exciting. Mr. Boston, what happened to bring me here? I don't know. Did you click a button somewhere? Did the show go okay? I'm still doing the show, Chad. You just got a Skype call. Yeah, I wonder who you're talking to. I think it's possible that Chad also works with my wife. Let's see. All right, let's do like one more question. Steve Coates, have to redeem myself and ask a good space-based question. How do we verify if other aliens are conscious? Yeah, same problem. How do we know, man? It was great. Click the record buttons and everything. Yeah, awesome. Yeah, I did it. Let's see. Has anyone gotten back to us on our question that we asked? Nope. Nobody's asked the question. Oh, it's too bad. Twitter is failing me. All right. Let me see. All right. Larry Beckham, am I excited to see Jeff Bezos fly? Yeah, I'm I'm excited to see New Shepard fly, and it makes sense for. Jeff Bezos is going to test the safety of New Shepard by being the first person to fly, or one of the first people to fly on it. That's brave. That guy's worth billions. He's got a lot to lose, so he's demonstrating the safety. I don't think people realize how much of a space nerd Jeff Bezos is. Obviously, he's a profit-focused monopolist who is responsible for a gigantic company that is causing all kinds of havoc on the economic system. But he's also a gigantic space nerd who was deeply inspired to get into space exploration by Bob Zubrin and Arthur C. Clarke and places like that. And the hope is that he will spend his wealth on helping ensure a future of space exploration. That would be great. So having New Shepard actually fly and be safe is a good first step. Good way to test out technology. Seeing New Glenn fly at some point would be great. I'm excited to see him be successful. I won't fly on it, but I'm excited to see him do it, and brave to take a shot. Okay. So, Mr. Bob, okay. All right. All right. Nuclear-powered plane in the atmosphere of Jupiter or Saturn should work, right? Yeah, I don't know. I'm wondering about that. What's the speed? How that'll work. All right, let's wrap this up, and then I'll stick around for the overtime. So I got to remember to do the outro, and then the Patreon bumper. All right, those are all the questions this week. Super fun. Thank you, everybody who both asked questions on the various YouTube videos, but also the people who join me live here on the Monday. It's super fun. Again, if you want to watch the show live, I do this every Monday at 5 p.m. Pacific time on YouTube. So you should come and join me. Here's the Patreon bumper. More questions in a second, but first I'd like to thank our patrons: Fred Manzella, Chris Copa-Bianco, Ross Daniels, Andrew Harmsworth, Peter Zerker, Philip Blanco, and the rest of our 825 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. All right, and the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. Did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right, I'm going to stop the recordings, but I'm going to stick around. Don't go anywhere. Okay. All right, now we'll shift into more live. I'll try and get all the questions that have already been gathered up. Lucas H., I just saw a video on another channel that talked about new models of star formation. I would need more specifics than that. Michael Harmer, hey Fraser, Halley's Comet. What odds do you give that the human race will land a probe on that comet around 2061? That'd be great. It'd be definitely worth doing. I think the odds are good. At this point. We've already landed poorly on a comet with Rosetta, so I can imagine there'll be more comet landing attempts, and Halley's Comet will be one of the best ones. So yeah, that'd be great. Kudizo, we can't see the beginning of the universe because of no light. We'd be able to study the early universe with gravitational waves when we have more sensitive tools. Yeah, in theory, we should be able to use gravitational waves to see beyond the cosmic microwave background radiation, which is pretty exciting. But you're going to need a much more powerful telescope. Yes, I did stop the audio. You're going to need a much more powerful instrument than the ground-based. We're going to need a space-based one. There's one called the Big Bang Observatory, which is going to be like 12 satellites in this giant configuration. In theory, that will be the machine that will be able to detect those primordial gravitational waves. It'll be one of the greatest observations by humanity to be able to detect the Big Bang itself in gravitational waves. But it's out there, in theory. Corey, have you looked at some of the tech surrounding the missions to Venus? Not the tech yet. I'll probably, I'm going to try and interview some of the people. I'll probably get like David Grinspoon and others. So, Ken and Lucas, what do you think about nuclear fusion power in China with their new tokamak reactor? Yeah, the Chinese were able to sustain fusion, to set a new record for sustained fusion. Fusion will be great. I mean, I think that, as we near this renewable like energy future with solar panels and wind power and geothermal and things like that, having something like fusion is not that important, but there's going to be certain segments where we really could use it for like baseload power and for applications where you need something more compact, things like that. So, or in places that are really heavily populated, like Europe. So I think, fusion's always 30 years away. So, it's nice to see the ongoing developments that take us to that 30-year goal from now. Pratik Chonan, do scientists use light signal patterns through any device to contact any potential extraterrestrial life in the past? If not, then can it be done in the future? I don't know what light signal patterns are. I don't know what that means. I'm sorry. Kirk Thompson, space mining and refining in situ space. Why consider returning tons to Earth? Use and build in space, but how to separate and refine in space? You have to, each one is a separate puzzle. You have to figure out a way to refine various raw materials in space without gravity, without human beings there to troubleshoot the problem. Like, it's going to be tricky. But there's been some pretty cool ideas suggested for each one of these. And so in the future, we're going to see lots of different experiments, people launching all kinds of things and eventually figuring out ways to build robots that are able to make more robots. Gregory Brown, what are your thoughts on the safety of launching the recently proposed nuclear reactors to power spacecraft? We already launched plutonium with some of the space missions. I mean, there was plutonium on board Perseverance, so my thoughts on the safety are exactly the same. Be careful. Put it in a capsule that if there's any accident, the plutonium isn't dispersed into the atmosphere. This is sort of already a solved problem. The Soviets launched 31 uranium reactors into space. The Americans have already launched one. Plus, there's all of the RTGs that have flown to space. So there's a lot. Be careful is the way you do that. Make it so that even if it explodes, you don't get the debris raining down, that the plutonium stays as a chunk and lands somewhere safe. Are they coming in faster than I'm answering them? All right, let me see. Let me sort of go down to the bottom now too. Cobalt 14 is more interesting than plutonium. Yeah, there's a lot of really interesting isotopes that have different power curves that release their energy. And so some like if you want to do like really long, like there's been these ideas for do like a 1,000-year mission using nuclear energy, and you just use a different isotope that releases at a much slower rate, and so you could sip away at that power for a really long period of time, as opposed to plutonium, which has a half-life of, I don't know, like very short. Like the Voyagers have been flying for since 1977, and they're almost out of power. So there's like different ideas on different kinds of isotopes, and we're just like, people haven't really started to explore this yet, but I think we'll see that in the future, where you're going to have different isotopes for RTGs and for nuclear reactors going at different rates for the longevity. And if you want to really be able to fly to another star system, I mean, you're going to be able to last for hundreds or even thousands of years. It's a cool idea. No. Planck, so Larry Beckham, Planck remnant left by primordial black holes, a dark matter candidate? No, I haven't heard of that. Carbon-14, yeah. The Patreon interview thing was from you Googling the wrong guy? All right, let's see. So you want to do a Venus mission tech episode. The Prince is a good book. I know it is a squeaky microphone. I gotta forget. I put it a little lower because sometimes I could bump into it with my beard. Is that loud? It's like turning into ASMR. All right. All right. Oh, chemtrails. Everything NASA shows us from space is cartoons. You too can be a cartoon in space. So NASA isn't the only thing that sends pictures from space. There's also the Russians. There's also the Europeans. There's the Indians with their mission to Mars. There's the United Arab Emirates had a mission to Mars. So there are many nations now that are sending spacecraft. Many nations own satellites. Like most nations have some kind of telecommunication satellite. So that's a pretty big conspiracy that you're going to have to add. You're literally going to need to have every single country. Millions of people are in on it? Billions, maybe? It's a big conspiracy to have it all like making cartoons. Yeah. And like, it's so funny because people like look at a picture that was taken by like a person with a telescope here on Earth, like an amateur with a telescope that you could do. Like you literally just go down to the store, buy a telescope, take a picture. It would look like that. And you're like, it's a cartoon. Like, what? What? Like you could take the picture. Like, don't you believe things with your own eyes? Don't you believe in the experiments that you can do? Yeah. So that's I don't know. I feel like it's just like talking points, maybe. Like someone told you that space is a cartoon, and you're not like willing to check it for yourself. So, almost seems like you're like easy to fool. Thomas Hand, can we expect James Webb near soon? So the James Webb launch has been delayed. It was supposed to launch Halloween, and now it's been pushed back probably to mid-November because the two previous Ariane 5 launches had problems with their fairing release, and so NASA wants to double check, which makes sense. All right. Yeah, it's funny. Like even the amount of detail that amateurs can get from the International Space Station. So like you can buy a telescope or even like use a pair of binoculars. When the International Space Station flies overhead, you can point your telescope at the space station and you can take pictures of the space station with its solar panels. You can see the radiation, the radiators, and you can see the configurations of the different spaceships that are docked to it. So if you know that, say, right now there's a Crew Dragon 2 attached to the space station, or a Soyuz capsule, you can actually see those spaceships attached to the space station. And then when they detach, you can actually watch it happening in space above you with your telescope that you bought, that you're looking through with your own eyeballs, and you can see all this stuff. So like explain that. It's pretty funny. I don't know what Hopf vibrations are. I don't even know what that is. Tree Farm, there was talk of a mechanical Venus lander rather than electronic. Is it likely? Yeah, there was a NIAC grant that was handed out a couple of years ago for some ideas for doing mechanical rovers. And NASA's still considering this, that the way you deal with the horrible heat on electronics is you just don't have any electronics. Just make the whole, make your whole rover some kind of clockwork rover, which is a pretty clever idea. And so there's ideas on, like, maybe it's got, like, it's wind powered, and it's got like a big propeller that allows it to push it around as it's moving along the surface. And as the propeller turns, the wheels turn, and as the wheels turn, perhaps collecting some kind of data in some way. You can imagine like a wheel that's on the top of the rover that's spinning around, and then it could be changing like colors that would be like ones and zeros. And so you could be watching this rover from space, and you could be detecting, like maybe bouncing a laser off this reflector, and you could be analyzing data. And so imagine, like, the simplest version, right? You got this clockwork rover, it's driving over terrain, and as the terrain goes up and down, it's changing some sort of, it's measuring the height of the ground, and then it's changing this reflector on the top of it. And so some satellite is watching this and is able to determine the data. So there's some really cool ideas. I do like it. I'm not sure though, because there's also some new technology on really heat resistant electronics that can handle the surface of Venus. So we might get where we don't need a clockwork device, but it's still a cool idea. Like, have you ever seen those like Strand beasts? These really cool mechanical things that walk along the beach. It's pretty cool. All right. Okay, I think reached the end of the overtime. So, okay, Matt Dowd is talking about the Planck remains. Well, Matt Dowd is the man, so we should watch him, not me. All right, well, thank you everybody for joining me live. I really appreciate it. This is super fun. I've got an interview scheduled for next week. We ran an episode about this, or we ran an article on Universe Today about this, about essentially a universal methodology for detecting life. And not just life as we know it, but life as we don't know it. So I'm going to be talking to the researcher who's proposing that. I think it's on the 22nd, 21st. I'll put it into the calendar. And just remember that everything goes on hiatus at the end of June. So we've only got 1, 2, 3, 4 more episodes of the various shows up until the end of the season, and then everything's on hiatus. So enjoy this time we spend together. All right, well, thank you everybody again. Thanks Nancy, thanks Chad, thanks to the mods, thanks Nightbot, thanks for everyone watching, thanks for everyone who asked a question, and we'll see you all next week.